have a mic? Can I have a rappel? No, it's okay. So being the last speaker, can I please ask you to feel very, very sorry for me and have all your empathy? Being the last one in the room. Well, glad that you guys stayed. So we heard a lot of talk about today on metrics, on observability, a lot of governance, how do you do better? The first thing we need to ask is, what is cloud native? And what does cloud native stand for? Why it's different than what we're doing previously? In my terms, I've been a software engineer. I've programmed, lead a practice. To me, it's really different. Cloud native is really the fundamental different ways of working. If you're still working in monolithic, you probably require a lot of human intervention. You write a lot of processes, you write codes, put them together, make it work. In cloud native, it's really about how do we use machines to work for us? How do we leverage the power of a machine, the power of all the technologies, all the options that you have heard today? How do we make it work for us so we can be lazy, right? So we can work less, we can work smarter, but not harder. So today I'm going to talk about it's really a lot of things I mentioned here, metrics, histograms, or traces. They are almost like the new measurements. And the way that we are charting for the new world, the way I like to think is we need to have a different mental model when we're approaching cloud native. It's a different mental model that we approach traditional on-premises 2-tier, 3-tier SOA architecture. So this mental model, we need different type of metrics, techniques to chart our maps. Sometimes our maps doesn't equal to our territory. So, okay. So my name's Annie. I work for VMware, application platform architecture. So, because I'm the last one, can I get some interactive session going on? Because I just don't want you to fall asleep. Right, so how many of you here actually write code? Awesome. How many of you actually monitors your code that runs in production? Okay, wow, no wonder you stay back. And how do you actually debug? How about SRE? Anybody here is SREs? You, 1, 2. Cool. Oh, 3, 4. Right. Now, so given that we code, as a software engineer, we write code. And we write code not because we write code, we put up on the wall. We write code because we're generating business values. And we only generate business values when our code actually runs in production. So today, I'm actually going to talk to you about, how do we in VMware think about running in production? What does running in production mean? What does running large-scale SaaS services or applications on cloud? What does that mean? So, yeah, speak ahead of me. So, and I do have a secret to share with you. Okay. So, it's that underpins the whole application monitoring and the whole observability that we heard today is the fundamentals of the only thing that matters is customer happiness. And it's so true in the cloud-native world. It's so true in everything that we do. We can have all this choice of architecture, all this choice of technologies, adjacencies. The only thing that matters to a lot of us is customer happiness. And I also have something to share with you that nines don't matter. SLIs, SLOs, SLAs, those things, if you take the Google book, if you read the SRE handbook, you need to really apply to your organization. They mean different things to different people, right? You could potentially have, and then the third secret I'm going to share with you is actually a very bold statement. You could potentially run a 5.9 application on a 3.9 infrastructure. Now we're defeating physics here, or if your infrastructure down, or your apps will go down. But how do we do that with 5.9? How do we get 5.9 application performance guarantee with 3.9 infrastructure? AWS 3.9s. A lot of people run really, really good customer service and high availability applications. How do they do that? If, that's a big if up there, is you understand, as the application owners, you understand what broke quickly. And you'll shorten your debugging time. That is the only way that you know how can you have 5.9s on top of 3.9 infra, right? So basically, how do we quickly understand what broke, and how do we shorten the debugging time? Is how do we keep 5.9s, and whatever that is, meantime to something happens. So I'm going to have very, very simple slides because I know you might not be able to digest all the words later in the day. In VMware, we have this concept called B-jobs. And this is really the high-level philosophy that we keep, is that it's about being lazy, about building for lazy. Building for lazy is not easy. Now, so about leveraging tools so that we can spend more time at the beach, right? It's about seeing. So as you can see throughout the day, in the last 5 years, sending data, collecting data, ingesting data, it's a solved problem. That problem's being solved. Now, storing data, that's mostly a solved problem. But the problem that's remaining is how do we making sense of data? How do we get correlated data? How do we actually make sense of infrastructure metrics, application metrics versus business metrics? How do we actually make sense of that? And that's a challenge that we are here to solve today. Or we're talking about how we're solving it in VMware. So you heard about observability, and I probably won't mention too much about it. But today, I want to talk about running production in scale. And then I think this morning we have a number of talks about how do we do application, how do we have heard talks on running applications in scale, ingesting data in a large scale. So in VMware, in this particular product stream, we are ingesting 130 billion data points per day, and we have 5,000 services in production. So, and guess, with that scale, how many SRE do we have? Just a random guess. So we have two. We have two. And because the factor is B-jobs. We want machine to do all the work for us, and we, as I go through the philosophies and how we're doing that, how we're achieving that in next step. So quickly, I think we have gone through this many, many times, but I do want to emphasize one thing. That is, we talk about metrics a lot today. So metrics in the new world, charting the map now. In the new world, metrics is, sequential data points, quickly measuring same thing, right? But something that hasn't been really mentioned today is histogram. Histogram is really the first-class citizen in the new cloud-native world. The way I like to understand histogram is it's almost like a litmus test for you to understand truth and false. For example, if I just said, generally, boys are better at maths than girls. That's a generalization, that's a perspective. Some people just go by for it. But if you lay the data out in a histogram, look at the overlays, you know that it's false. That's the outliers actually, if you're talking about average, that might be a statement, but if you look at the outliers, you know that this is not the fact. So histogram is talking about distribution, the frequencies of data in buckets, and it's very, very important in a cloud-native world that we understand latency. And this is the only way that we do it truly and in a raw data form. And tracing, I think we have mentioned a lot of those as well already, so I'm probably going to skip. So how do we do bit job the wrong way? How do we do a bit job using the current tooling that we have, or the logging and diggings that we have, or no? So how do we do it wrong? Is don't know where to start. When something happens, when the API down, you have a slow performance, where do you start? So if you're probably working over the VMware stand, I had the apps going on this morning. Basically, I have an ordered shirt API. Now, so I had the order shirt API. What's the request call flow? You don't know where it hits. Or, what are the service dependencies? You're asking those questions. Health of the services involved in the request? You don't know. Now, how many customers having this problem? Because if you do a SaaS service, you have different tendencies, you have different customers. How many of your customers affected? Is it entire fleet or just a particular region? Now, what is the median? What is the average? What's the 90 or 95, 99 percentile? Or potentially, if you want to really, really go down to the stats, what's the 99.9 or 77.7%? Which particular customer, which particular request having this latency? Or you can't identify and solve the bottleneck services. You don't know where the bottleneck is. If you don't know where the bottleneck is, it will take you forever to actually pinpoint, to actually solve the problem. That is absolutely, if you have measurements, you have metrics in place, it helps you pinpoint that bottleneck. And once you find out the bottleneck, you know where to start. So you might be looking like this guy and start digging the logs. That's not how you do bit jobs. The bit jobs, the right way is you have the 3D observability platform. You will need to use the fundamentals, the charts, the new toolings that you need to have that understand metrics, histograms, and also traces. So this gives you a complete picture of what you need. So with the 3D observability platform, you'll be somewhat looking like this guy. Look like how happy he is. So let me show you how he will go about working and debugging his applications. So he will start with application level tracing. You have the traces, you have the relationship between the services, and you're understanding where your bottleneck is. Okay. The next one, because we are in the, we're looking at cloud native world, we start looking at SREs. So we have a metric that we keep, which is the red metrics: the request, the error, and the duration. Those are the 3 metrics every SRE will look at. And that's every single thing throughout the observability platform is we look at the red metrics to identify where the error is. And then the next step is we actually look at the service map, right? So understanding the microservices, how they relate to each other, and at the right-hand side, you get the red metrics again. How clicking into each one of the microservices, understanding the delays, understanding the requests, the error, and then what do you do? And then we use a lot of maths, and we use a lot of science, and to actually correlate all these data to see, using all these maths, query languages to actually understand the data that we ingest. So using query, using maths, using science at the back to actually find out where the problem is. And we write complex queries. And also we write complex queries, and we also design very complex alerts. Those alerts, what that means is, in our philosophy, is we're engineering away the alerts. We don't immediately, we respond to alerts, but when it happens once, we want to find out ways how we're not responding to the same alerts ever again. It is a way of thinking that once happens, you want to use science, maths, engineering to remove the amount of human interventions that's required. So we do use a lot of, in terms of building queries and building alerts, in terms of trying to remove the amount of interventions. That's why how we can do this with 2 SREs with this production scale. Now, so we build charts, again, to explore the systems, to actually understand the anomalies within the system, trying to get a needle from the haystack, trying to pull out attract anomalies through queries, again, science and maths. And eventually, you can choose which one will be the happy guy at the end. So I think I have a really, really short talk, and I'm probably not going to talk a lot more, but this gives you an idea how we use a platform that does, using the metrics, histograms, and traces as a fundamental ingest data, and using the query of the platform, the analytics of platform, trying to be as smart as we can in terms of solving the problems and removing the amount of human intervention as possible. So just to recap, really, as we're charting the new world of cloud native, we need new terms and languages, and metrics, histograms, and tracing. You'll be hearing those a lot more as we go on. And the only thing that matters is everything that we're talking about, everything that we're trying to work for is to achieve, the only thing that matters is customer happiness. That's it.